Next type complex. In this type of complex, AB is an unsymmetrical bidentate ligand. We all know example of this type of complex as Cu del by 3 and Cr del by 3 where like NH2CH2 Cu minus the facial meridian isomer of Cu del by 3. So in this type of complex, it shows unsymmetrical bidentate ligands. For example, the glycine NH2CH2CO minus will show facial and meridian facial, so cis isomer, meridian show trans isomer. So here, this is show facial isomers. Okay. This is the cis isomers, and this one is the meridian isomer where donor atom is opposite to each other. In facial isomer, the three N donor atom occupy the corner of trigonal face, and the 3 oxygen atom occupy the corner of the another trigonal face. And in other words, we can say that in the facial isomer, the 3 possible N cobalt and bond angle are 90 degree. So this facial isomer here, 3 N donor atom, they occupy the corner of her trigonal face, and the 3 oxygen donor occupy the corner of another trigonal face. In other words, this facial isomers, the 3 possible NCO and bond angles 90 degree, but in media isomer, the NCON show 2 different bond angle, which is 90 degree and 180 degree. The complex of CO di-N NO2 3, where di-N is ethylene diethylene amine, NH2CH2CH2 NHCH2CH2. Here facial isomer are adjacent to each other, and NH2CO NH2 showing 90 degree, but in meridian NH2CO NH2 show 2 different bond angle, which is 90 degree and 180 degree. So meridian is trans isomer, facial is isomer. The complex of CO di-N 2,3 plus also exists as facial and meridian isomers. Facial isomer and this one is meridian isomer. In facial isomer, the 3 N atoms of di-N ligand lie on the corner of a trigonal face. That is the 3 possible NCON bond angle for di-N ligand 90 degree. Meridian isomer NCON bond angle on 1 NCON bond angle for di-N ligand are 90 degree, and other is 180 degree. Ma2B2C2N plus minus type of complex ion PTNS3 2PY2Cl2 2 plus is an example of Ma2B2C2N plus minus type complex. The positive geometric isomers are shown: PyNH3ClCl, Py and ammonia, NHClCl 2 plus Py, the 5 possible geometric isomers. So in this Ma2B2C2, here 3 different kind of ligand are there. and it is in the ratio of 2. So it shows 5 isomers, 5 possible isomers. Ma, B, C, D, E, F. PT, PY, NS3, NO2, Cl, Br, I. So here 3 different ligands are there. There is only one coordination compound of this complex. This compound can exist in 15 possible isomeric form, but only 3 isomers have been isolated. So this kind of complex, 6 different ligands can show 15 isomers, but only 3 isomers are being isolated experimentally. MAA2A2 N plus minus. A is a symmetrical bidentate ligand. So A is a monodentate ligand. Some example of this type of complex: CuN2Cl2 plus, CuN2NO2 2 plus, CuN2NO3 2 plus, other C2O4 2Cl2 3 minus, etc. The possible geometric isomer: CuN2Cl2 cis isomer, 2 donor and same donor atom are adjacent to each other, and the 2 donor atoms are opposite to each other. Then MAA2AB N plus minus type complex. MAA2B2 N plus minus type complex. Some example of this type of complex are CuEnNH3 2Cl2 plus, CuEnPy2 Cl2 plus, etc. The possible geometric isomer of CuEnNH3 2Cl2 plus are shown. So here 3 isomers are there, where 2 ammonias 1 and 2 cis form, then ammonia 1 to 6 trans form, and ammonia 2 and 3 cis form. So here 3 isomers are there. So in the first, both the ammonia ligands are and both Cl minus are on adjacent. Then in isomer 2, ammonia are opposite and Cl minus on the adjacent position, whereas in isomer 3 the Cl minus ligands are opposite and ammonia ligand are adjacent position. So MAB2A2 N plus minus type complex. An example of this type complex: COGLY2Cl2 minus ion. The geometric isomer of this complex: first one ON ClCl ON 3 ON ClCl NONO gly ClCl ONO gly. Geometric isomer of C gly 2Cl2 ions. MAB2 ABN plus minus type complex. An example of this type of complex is COGLY2 NH3PY plus ion. The geometric isomer of these complex ions are shown in figure 2.34. Here ONO ammonia, ONO in the first, NO is opposite to each other, is actually adjacent to each other. Here also adjacent to each other. Here these are NN are opposite to each other, but both the O is adjacent to each other. Here NN is adjacent to each other, but both the O is opposite to each other. Then NN and O both are adjacent to each other. NN and O are opposite to each other. Octahedral complex contain optically active bidentate ligand PN. An important example of this type of complex is CO, En, Pn, NO2 2 plus ions, where En CH2, NH2, NH2 ethylene diamine, then Pn is propylene diamine, CH3, CH2, CH2, NH2, NH2. So this is active bidentate ligand, which is optically active, and it shows geometrical and it shows octahedral geometry. The possible geometry isomer of CO, En, Pn, NO2 2 plus ethylene diamine and propylene diamine. Cis form nitrogen nitrogen. NO2 NO2 are adjacent to each other. Nitrogen nitrogen. NO2 NO2 adjacent to each other. Then NN are adjacent to each other. NO2 are adjacent to each other. Here NO2 NO2 are opposite to each other. So it is trans isomer. There are two cis isomer and only one trans isomer. So in this complex, two cis isomers are there and one trans isomer there. There are only three geometrical isomers. So there are three geometric isomers there: CO, En, Pn, NO2 2 plus ion. Since propylene ethylene diamine is unsymmetric optically active bidentate ligand. Propylene ethylene diamine is unsymmetrical optically bidentate ligands. So its donor atom is nitrogen atom are differentiated by marking 1 and 2 asterisks. Next is polynuclear complex. The geometry isomer of bi-di-nuclear bridge octahedral complex of Fe2OH 4H2O6 2 plus. So this dinuclear bridge octahedral complex show geometry isomers. This geometric isomer of FeOH H2O2 plus. All the 6 ligands are the same water molecules. So how to identify between cis and trans isomers?